I have made another copper sulphate electrode. I found a plastic tube, cut a hole in the bottom, glued a copper rod into place. I then cut a wooden plug for the top, put a copper sulphate crystals in and added ionized water. This now looks more like the half cells that you are used to using on site. And that is the reason why I made this one. I will now test it against the copper sulphate electrode that I have already made and used in this series of videos. That's this one. As you can see, I have set the meter up on voltages and I have connected the red and black leads to a piece of copper which is in the saturated solution in this test half cell that I have been using. I have done this to set the meter at 0, as you can see. I now take the connection out and connect it to the other half cell, and as you can see, we have a difference in the reaction potential in this half cell to the reaction potential in that half cell of 11 millivolts. Now, you will notice that this has no return path, so it's not a complete circuit. It is just that the meter is saying that the reaction potential in this is 11.2 millivolts different to the reaction potential in this. However, if I take this connection, which is the equivalent of a Lugin capillary, I have now connected the electrolyte in this container to the electrolyte in this container. So you have a situation that is called in science the Daniell cell, where you are comparing the reaction in this vessel to the reaction in this vessel. And you can see this is the equivalent of a salt bridge, and you can see that we have 15.6 millivolts difference between the potential of this reaction, the electromotive force of this reaction, and the electromotive force of this reaction. The reason why I have taken this out and put it in this position is because when I put it on the ground, it gradually siphoned the liquid out of here and into the lower vessel. This proves that this is in fact a half cell as per standard and as per used in the laboratories. It is half of a cell. Copper sulphate. This is half of the cell. and this is the other half of the cell. So we have a cell, and this is a half cell. I hope that makes it clear that we are using half of a cell, and this is not what the Nernste equations quote. The Nernste equations and the Pourbaix diagram actually refer to a half cell reaction. Okay?